Yeah, switches or layer 2 device. So we are learning layer 2 concepts. MAC addresses are the decision maker while forwarding the packet, not the IP address. So what controls the forwarding of packets? It's the MAC address. So the control plane works based on MAC address in the switches. Whereas on the routers, it is the IP address. Okay. Now the switch needs to know to where the packet needs to go. For that, it looks into the incoming packet's destination MAC address. Source MAC address when the packet enters this particular port, let's say this is F0/0. When the packet enters, sorry, not 0/0, it will always start with 0/1 on switches. There is no 00. On routers, we have 00. On switches, it's only 01. As the traffic enters, as the frame enters, the MAC address, let's say this is A, this is BBB, and there is a MAC table. As the traffic goes from computer A to computer B, the source MAC address will be A, and destination MAC address will be B. When the packet hits the port, in the MAC table, it learns the source. And then it will check the destination MAC address. If destination MAC address port is known, it will do unicast. But you see, the switch do not know. The switch don't know where is BBB. The switch don't know where is BBB. So what it does, it will flood. It will flood the packet to every port. It will flood the packet to every active port. For example, if I have a computer here, that will also receive it. If I have another computer here, F0/15, all receive it. Whichever the port is up, via those ports, the packet will be forwarded. This flooding happens only when the destination is unknown. This is the first time the packet is going to BBB. So far, BBB has never used the switch. So switch don't know where is BBB. The packet that goes here with this MAC address will be dropped. Why? The PC says, I am not BBB. Why are you disturbing me? This also will drop because I'm not BBB. This guy responds. When the response is sent out, the source MAC address will be what? And the destination MAC address is AAA. From there, only we receive the packet. Now, when the switch receives BBB, it learns immediately from the source MAC address and the port from where the traffic enters. It knows that F0/24 is connected on BBB is connected on F0/24. Now, where it wants to go? To AAA. It will check the MAC table and it will forward the packet via this port. No flooding, only unicast. Understand very well. When the destination MAC address is not seen in the MAC table, when the destination MAC address is unknown, when the destination MAC address is unknown, it is going to flood. Sorry. It's going to flood. When the destination MAC address is unknown, it is going to flood. If it is known, there is no need for flooding. It knows which port has got that destination connected. A is connected on F02, so the return traffic from B is not flooded to CCC or DDD. So flooding is also there, forwarding is also there. When it will flood, when it will forward? When switch will flood, when switch will forward? No answer. If the destination is unknown, what? Destination is unknown, what? If destination is unknown, what it will do? Broadcast, it will flood. Okay. When the destination is seen in the table, it does unicast. Broadcast is bad. You know that? Broadcast is bad. Why? Because everyone is going to be disturbed. Everyone is going to receive. There is no security then. Everyone is going to receive. But good thing is, it's only the first packet. The first packet, you don't have much important informations in any conversation. You won't have any much important info. So it's okay. See, sometimes switch will also flood all the time. Reason is the MAC table is full. There is no place for new MAC address to be learned. So if you don't learn the MAC address, then it will not know the destination. If it will not know the destination, you just say it, it will flood. Correct. This is only possible if the switch is under attack. If an attacker comes and fills the complete MAC table with a lot of MAC addresses of attacker, then there won't be any space for the original genuine MAC address to be learned in the MAC table. During the time, whatever comes, won't find any destination MAC address because there is no MAC address learning happens. So flooding always happens. We'll talk about that later when we come to CCNP, how this can be solved. Now we are just learning switching. Forwarding if the MAC address is present. Flooding if the MAC address is not present. Okay, next. The switches will have only one VLAN by default, and that VLAN is identified with the number 1. This VLAN you cannot delete. I'm repeating. You may get a question. Can we delete VLAN number 1? You cannot delete. By default, this VLAN will be there. You cannot delete. All interfaces will be the member of this VLAN. So you cannot delete it. Even if there is no interface to this VLAN, let's say I created some VLANs and I took all the interfaces from VLAN 1, I have taken all the interfaces. Even then cannot be deleted. VLAN 1 cannot be deleted. So you no need to create. It is already created. Okay. It cannot be created nor deleted. So VLAN 1 is default. But there are 4 more VLANs which are seen default, but they are not called as default. So if in an interview they ask you, what is default VLAN? You should say default VLAN is 1. But when you take a switch and see, you will see 4 more VLANs. You see? So VLAN brief. These 4 VLANs also by default will be there, but they are not called as default VLAN. This is the only VLAN called as default VLAN. This is FDDI default, token ring default, FDDI net default, token ring net default. What these VLANs are? Why do we have these things? See, according to the industry standard, according to the ISO standard, when you develop an operating system for a switch, these need to be there by default. These 5 things, 5 VLANs. VLAN number 1, VLAN number 1002 to 1005. Cisco don't support all these things, but still it is there because of standard. So you should not call this as default VLAN because we don't support this and no interface is mapped to this. If I try deleting, you see it won't get deleted. No VLAN 1005. See, the default VLAN 1005 may not be deleted. No default VLANs you can delete, but this is the only one we should consider as default VLAN. If someone is asking you how many default VLANs are there by default, 5. But that's the right answer, but most of the people don't agree with this. So better you say there's one VLAN called default VLAN, but there are also 4 other VLAN which is not at all supported. It is there because of the industry standard. VLAN number 10023455. Mostly, in CCNA level interviews, it won't go that deep. They will not. If you say VLAN number 1 is default, they will agree and they go next question. But only when you say there are 5 default VLANs, then they have doubt. Sometimes they may not know also. Then they will start asking how 5. So better try stopping with that one thing. Default VLAN is 1. That may solve the problem. Next. Creating VLANs creates broadcast domain. What is broadcast domain? When a broadcast is sent on one of the port, it will go to all the ports because all the ports are in single VLAN, which means this is one broadcast domain, one group. If I shout from here, only you will hear me. Even my next room, people cannot hear. Which means you are in my broadcast domain. We are in single broadcast domain. Not network wise. Only you can hear, no? So me and you are in single broadcast domain. Others can't hear. So when 5 more people join this class, let's say, they also become member of same broadcast domain because they can hear. Whoever can hear, they all form one group that is called broadcast domain. But don't compare what I said with the real network. In real network, we are not in single broadcast domain. Only voice. My voice makes you to feel like that. As if, you're all sitting next to me in the same room. But reality is not that. You have internet. Anyway, so you see, if all ports are in single broadcast domain, then every now and then someone is going to do some sort of flooding, which will go to all other members. ARP will do later flooding, DHCP will do later flooding, and if switch don't know the destination, then also it will do flooding. See, if every device is flooding all the time, if all the devices are flooding every now and then, not all the time, every now and then it will be too busy. The broadcast domain will be too busy. So to avoid that, we can break the broadcast domain into small broadcast domains by using VLANs. By creating more VLANs, we create multiple broadcast domain. Like this, as I said yesterday, you go to global configuration mode and say VLAN 100, name it like sales, and then go to the interface, one or multiple interface. I have multiple interfaces. Say, for example, interface range F0/5, comma F0/10, comma F0/15. All these three interfaces, I want it to be a member of VLAN 100. So I say switch port access VLAN 100. See, you don't need to go to every single interface to do this. You can use the range command and put them in VLAN like this. Let's go verify. Show VLAN brief. You see, interface called VLAN called sales and interfaces called 5, 10, and 15 is taken from here. You see, after 9 there is no 10. After 14 there is no 15. It is because it's been removed from that broadcast domain and it is now in this broadcast domain. If any device send a broadcast packet to this port, only the two other interfaces will receive it. Because this three interface alone is in single group. Did you understand broadcast domain? Now, how many broadcast domain by default? Only one. Now how many? Two. Now there is another word called collision domain. Collision domain is on every single port. To avoid collision, they learn MAC address so that they don't need to flood every time and form collision. To avoid collision, they learn MAC address so that they can do unicast. Always flooding will form collision. So every port is a collision domain. If I have 24 port, then the switch has got 24 collision domain. But the broadcast domain is 2 here. The default is 1. Collision domain, you cannot reduce it. If you have 24 port, then it is 24 collision domain. But broadcast domain will vary. By default, it is only 1. But when someone creates VLAN, then the broadcast domain, number of broadcast domain increases. Now you see, I'm going to delete this VLAN 100. How do I delete? Like this. No VLAN 100. That's all. Now I have only one broadcast domain, you see. The ports which I mapped to F0, mapped to VLAN 100, still not appearing here. Because I can show you, still this configuration is here. But the VLAN don't exist. The port says, hey, I belong to 100, man. But where is VLAN 100? Let me save this and reload and show you. This is switch now. I cannot off it. I will reload. What I'm trying to show now is the interfaces. We will come back to default VLAN. Show VLAN. But in this simulator, it is not coming back. When I remove the VLAN, even this line that we configure under the interface should get removed because the VLAN 100 doesn't exist. Listen, I'm going to this interface. Switch port access VLAN 100. Do we have VLAN 100 now? No. But when I hit enter, it will create, you see. Let me show you. Show VLAN. Look at this. It has created. Because on interface F020, I said VLAN 100. So this is another way of creating VLAN. VLAN can be created directly on the interface as well as globally, like before. We can create VLAN in two ways. One, go to global mode and say VLAN 200. This is one way. Now I'm going to go to this interface you see, interface F0/18. Straight away I'm going to say switch port access VLAN 300. Did I create 300? No. But you see, the VLAN does not exist, but creating. Let us verify. Show VLAN. You see, VLAN 300, we did not create. We directly went to the interface and say you belong VLAN 300. Immediately got created. VLAN 200 I created, but I did not assign any interface. Is that clear? Okay. Next. See, there is a protocol called spanning tree. We don't call it as STP. We call it a spanning tree protocol most of the time, but sometimes people will say STP, which means it's a spanning tree protocol. This protocol is enabled by default. It is running by default on our switches. What is the purpose of this protocol? Layer 2 loop prevention. Layer 2 loop prevention. In order to prevent loop in layer 2, this protocol is already enabled, which means in layer 2, loop is possible. That is why it is enabled to prevent it. All Cisco switches will have this protocol enabled by default in order to avoid loop, which means loops are very likely to happen, very common to happen. So to avoid that, you got spanning tree protocol. This is spanning means what, like spinning around, going around. This protocol will go around the topology and check whether there is a possibility of loop. And if it finds that this particular topology is loop, then it is going to put a tree on the road to avoid the loop. You see, if you go to some big um, office, what do we say? Tech parks. If you go to some tech parks, you enter in one gate. The day before yesterday, I went to Prestige Tech Park, Bangalore. You enter into one gate, big gate, and you go like this, and you see big building, and it goes like this, and then you go like this, and then sometime you will come back again to the same place. But you should have taken this left here. But you did not take that left, even though there is a left, you did not take that left because you thought that you should go this way. Because many people are going this way because it's an exit, but you don't know, you are new here. So what happens, you keep going like this and you end up here. Instead, if they do like this, if they put one gate, then everyone will come this way only, and then they may find a way out so that people who wants to go to the companies here will not loop. If you don't have this particular gate, there are chances that you keep coming back to the same place. Again you start again, like 3-4 kilometers inside the campus. Now again you take loop because you don't know that this is the left that goes to this building. Everywhere building, we don't know which exact location, which building we are in. This really happened. So whenever there is a multiple paths, see, to go to this building, this is also one path. This is also one path, which means loop is possible. Whenever you have more than one path to a destination, loop is possible. So this spanning tree protocol uses a tiny packet called BPDU, which is sent every 2 seconds from every switch on every port. So if the BPDU goes this way and comes back this way, then the switch knows that there's going to be a loop. I send the BPDU this way, it is coming this way, which means there is redundant path. I have to prevent this loop. So what immediately the spanning tree does, it takes a big log and puts that log here, so that if someone accidentally comes back here, he will go back. He won't keep looping. He will go back. The tree which is placed on the path prevents the loop. Yeah, it's the same thing going to happen between the switches to prevent loop. Let's see. When you have sorry, a switch with multiple paths, one of this path will block and become standby link. So there is only one active link. If any broadcast packet goes, it won't come back because there's a block. If you don't have the block, the broadcast packet will come back here, again it will go back here, again it will come back here, again it will go back here, which is looping. But the STP protocol, what it did, it understood there are chances of loop because the BPDUs are sent every 2 seconds. What is BPDU? Bridge. Protocol. Data unit. Bridge protocol. Data unit. BPD. So when the BPDUs are sent, the switches understand that there are chances of loop. So it blocked one of the port so that that link will be only standby link. On the standby link, the packets will not be forwarded. Only if this link goes down, this block will be removed. And then the forwarding can happen. The block will be removed only if the active link goes down. This will become active. So by blocking the port, STP prevents loop. Spanning tree prevents loop by blocking. More about spanning tree we are going to see in coming class.